All right, everybody, we are back for more. Whew. Number 4. Hopefully, you have finished now number 4. Make sure that you have 4 done before you watch this video. So if you haven't done it yet, pause the video and then start it again once you've actually made an attempt at trying to figure this out. Now, I will, if you haven't done it yet, I will try to remind you that this says an object moves toward the 0 position at a steady speed for 10 seconds. We know what steady or constant speed looks like in a motion map, in an XT graph, and in a VT graph. We also know, now that we've done number 3, we know what it looks like to stand still on a motion map, an XT graph, and a VT graph. So make sure that you think those through about how to construct these things. Now, for those that already did it, and you don't need to pause it, here we go. Toward the 0 position. Well, I'm going to do this. There we go. So that, for me, says what the statement says. I have an object that's moving toward the 0 position. Now, is it a steady speed? Well, what tells us that? First of all, my arrows are the same length. That means steady speed. That's constant speed. Constant length arrows, constant speed. Here, I'm showing that the object stands still because these dots don't have any arrows, and so we have now the object that's standing still. So, that's my motion map. Yours may not look like that. Maybe you didn't make yours like that. We'll talk about what that could look like here in a second. But, based on my motion map here, I've got to figure out what my position time graph looks like. Now, what I'm going to ask you and myself here, I'm going to ask, how do I describe my arrows on my motion map? What direction are they? They are positive. Oh boy, positive. They're positive. What are they? What is their length? They are constant length. Constant length. All right, so we have constant length arrows, and they're positive. Now, what we said on the previous slide, I said the words you use to describe the slope are the same words that we use to describe what? Velocity. Now, I'm going to add this to it. However we describe the arrows in our motion map, that's how we describe the slope of our line, which is how we describe the velocity. So I hope what you're seeing here is this. These arrows are positive direction and constant length, which means my slope on this graph has to be positive and constant, which means that's what my velocity is, a positive constant velocity. So, question. How do I draw a line on my position time graph that has positive slope and is constant slope? And based on my motion map, starts with a what? What kind of position is that? That's 0. Out here are positive positions. That means over here are negative positions. So my line has to start with a negative position with a positive constant slope. So I hope that you've thought through this and you can think that it would be like this right here. Starting with a negative position and then going up toward the t-axis, which would be the 0 position. Now that's the first part. That's just this part. That's my arrows. How do I show that the object stopped? And notice my dots are short of the 0 position, not all the way to the 0 position. Why do you think I stopped my line here short of the 0 position? Because my last arrow did not get to the 0 position, and my object is at rest now, standing still, short of the 0 position, which means now this section, how do I show that I have 0 velocity? With a line that has what kind of slope? 0 slope. And 0 slope means, oh no, gee whiz. Erase that. Back. Oh, sheesh. Ooh, that's pretty good. That's pretty good right there. So that is a 0 slope line to indicate 0 velocity. Everybody got that? Now again, I hope you're catching all the details. Started with a negative position. Started with a negative position. Traveling in the positive direction, that means positive slope. That's a positive slope because it was going toward the 0 position. The only way to get toward the 0 position when you start in a negative position is for the line to go up this way. Then it stopped, no motion at all for a period of time, a period of 10 seconds in fact. So really, when you cut this in half, this much has to be 10 seconds, and then this much has to be 10 seconds. That's how that works. Have we got that? All right, good. Now, the VT graph. Again, I'm going to ask you, how are we describing the velocity in this part? This part, velocity is positive and constant. Positive and constant. How do we describe the velocity in this part? 0. So the velocity is positive and constant in the first part. It is 0 in the second part. Now, how do I make that look over here? How do I draw a positive constant velocity over here? Where are the velocities positive? Yes, up here. The top part is where the velocities are positive. Positive and constant. How do I show it not getting bigger or smaller? Well, if it starts positive and it doesn't get bigger or smaller, it should just do something like that. I hope that's what you're thinking. Positive, constant velocity. Then I have a 0. 0 velocity. Where is the velocity 0? On the t-axis. So that means at the end of that first 10 seconds, now it's at the t-axis like so. So again, that section is positive constant velocity. This is 0 velocity. This represents what that represents. This represents what that represents. Okay, now back to the original. Oh, this thing, I decided that I was going to have my object start in a negative position, traveling toward the 0 from the negative side. Could you, and I assume some of you did, have the object start with a positive position and travel toward the 0 position this way? I assume so. That seems like it still satisfies the statement, so I'll draw my first dot out here and go toward the 0 position, and start out here and go toward the 0 position, and one more toward the 0 position. So there's my arrows there, and then I gotta show that it stops for a period of time, and so it stops there and there. Wow, these dots are terrible. There. So it looks literally, I mean, it's the mirror of the other one, because our statement, again, what does it not tell us? It does not tell us where the object starts. It just says moves toward the 0 position at a steady speed. Well, is this toward the 0 position? Yes. Is this toward the 0 position? Yes. Both are correct. Now, what I hope you're getting from all this is that there is information missing in this statement. There was also information missing in statement from number 3. It just told you the object was standing still. It didn't say where it was, and so that means there were multiple correct answers for that one. Now I have another question. How many correct answers were there for number 2? So the number 2 on this worksheet that you're looking at right now, how many correct answers could there be for number 2? Read that statement. Read the actual statement, what it says. It says the object started at the 0 position, moved in a positive direction with a constant velocity. How many right answers is there? I hope you're thinking 1. Number 2 only has a single correct answer. And why is that? Because all 3 parts of how we describe motion were mentioned. The start was mentioned. The direction. And the velocity. All 3 were mentioned. Now, what was not mentioned in this one? Object moves toward the 0 position at a steady speed and stands still for 10 seconds. Now, is toward the 0 position a direction? No. That's toward the 0. That's toward the 0. That's not a direction. So we don't have this. That's why we have 2 possible correct answers. It doesn't even tell us where it starts, just toward the 0. So we're missing a couple bits of information that we have to then fill in ourselves. So I hope what you're getting from this is that if you don't include all 3 of these bits, there's going to be more than one answer, and we don't want that. We want to describe the motion well enough that there's only one right answer. Now, back to the blue stuff. How do we draw a position time graph that looks like what are blue arrows and dots? Well, how do we describe these arrows here? What direction are they? Now they're negative. Those are negative direction. Are they still constant length? Yes. So it's constant, but it's also negative. So constant, negative. How do we draw a constant negative slope? Remember, because these are the words that describe slope, which are the words that describe velocity. So negative constant slope, negative constant velocity. Starting in what kind of position? Starting with a positive position toward the 0 position. I hope in your mind you're thinking this right here. That's what is happening now. So this motion map should be showing something like this. And once it gets to the part where the object stops, then it's just, oh boy, that's supposed to be horizontal. Just pretend that was a nice clean horizontal line. So again, this is like a mirror flip of the other one. Hopefully you see that. Flipped up from the bottom. Again, I hope this is making sense. And lastly, how does this look over here? Well, describe this again. We described it as negative and constant, right? Negative constant. Negative constant slope, which means negative constant velocity. Where is velocity negative? Down here. How do you show that it's negative and constant? I hope you're thinking this. So, I draw my blue line starting over here, like that, like there, like that, like that. Oh no. Jeez Louise. There. Now, finally, I didn't think we were ever going to get there. Finally, although, hey, it's not quite 15 minutes yet. Oh, I'm sure it'll get there. Now we have to show 0 again. That was negative constant. Now we have 0. So where is 0? Up, you guessed it, right up here. So right next to the red line that's horizontal. Oh no, I hope this works. Oh, now you can't even tell. You can't even tell there's 2 of them. Hold on, let me get the red back out. There we go. Red and blue together. How neat is that? That's pretty neat. Hold on. Oh, sheesh. Get the. There. Oh, that's nice. Now they're pretty much equally showing there. So the point of this is, again, this one gets flipped down. This one got flipped up. Oh my gosh. This one got flipped left to right. So again, I hope I know this can be kind of confusing. I hope that you're seeing the one that you made and then understanding how that's supposed to look. And then, again, seeing the one that you didn't make, maybe, and then looking here to see how it should have looked had you picked that way. And again, another 15-minute video. Holy mackerel. This is taking forever. Okay, let's move on.